IIT Bombay professor, in collaboration with Tata engineers, had made this happen in the laboratories. We just have to transform it into the ground reality. And I hope all the paperwork gets done and it is implemented to all the nitrogen industries. Hey guys, in this video we're going to be talking about a solution to the shortage of medical oxygen in the country. You all know that people are searching for the beds and oxygen cylinders day and night in this era of COVID. So for this, a professor of IIT Bombay, is from Mechanical Engineering Department, Milind Attrey, gives a solution to the shortage of medical oxygen in the country. The solution is very efficient and it's very fast. The reason being is the whole infrastructure for this solution is already been set up in the country. So, do you know how nitrogen production takes place in our country in general? Mainly, nitrogen is produced from the PSA method. PSA stands for pressure swing adsorption. You must be wondering why I am talking about nitrogen. This video was meant to be for oxygen, right? There is a reason behind it. We could convert those nitrogen plants into oxygen plants, nitrogen PSAs into oxygen PSAs. You must be wondering how. Yeah. Keep your curiosity in the pocket, I'll tell you. So first of all, to understand this, let me tell you how nitrogen is prepared or how nitrogen is produced. This is very important to understand in order to understand how it is converted to oxygen PSAs. Okay, this is the air. Air constitutes of three things, mainly three things. Other gases, nitrogen and oxygen. I have combined other gases in one packet. So this is the air. Now here is the compressor. This air is then pumped through the compressor. Now as it reaches the compressor compresses it and put in to a box or a tanker, you can say it, a container, which stores this, okay, the air, the compressed air right now. So outside the atmospheric pressure is 118, you know that, and now inside the air is being compressed. The reason being quite simple, you have studied in this class lab. Now after the air is in compressed tanker or compressed container, it goes through a filtration process wherein the air is filtrated. Filtrated with what? Filtrated with other dust particles, other residues, water vapor and all those stuffs. And all those residues has been thrown out of the system, the whole system that we are preparing right now. Okay. Now after filtration comes the most important process. This is a very, very important process to you. It's called adsorption. So there is another container over there which is called as adsorber. This container, its name is only adsorber, okay? In adsorber, there are molecular sieves which are responsible to segregate nitrogen from the oxygen. And after that, nitrogen is collected in a buffer container and further it is being transported to all the places, all the industries which needs nitrogen. So I'll explain you how these molecular sieves work, okay? The working of the molecular sieves is very interesting and that is what I'll explain you further. So this is the molecular sieve as you are seeing in your screen, and this molecular sieve is nothing but an adsorbent material. What does an adsorbent material do? It is capable of absorbing some substance into itself. So by now, you must have figured it out that this adsorbent material will absorb oxygen into itself and let go nitrogen through it. So here are the gases you can see. The red dots, the red bubbles represents the oxygen gas and the green bubble here represents the nitrogen gas, okay? So currently these gases are in adsorber, the one which I showed you in the previous screen. Here is the molecular sieves and here are the green and the blue dots, the gases, nitrogen and the oxygen. Now these gases will pass through the molecular sieve, that is the adsorbent material. As you can see, the green bubble is passed through the molecular sieve, whereas the red bubble is being absorbed by the material. This is the whole game by which we segregate nitrogen from the oxygen. Now you must be thinking how the hell this is happening or the science behind it. So this molecular sieve, this adsorbent material is made up of carbon, and carbon has a special property to absorb oxygen into itself because of the kinetic diffusion that takes place with oxygen and carbon. So this was how the nitrogen production takes place in the industries, but we have to produce oxygen. So how are we going to do that? We just have to replace this molecular sieve. We just have to replace this adsorbent material with any other adsorbent material. This is of carbon. We have to replace this. And what we'll do is we'll replace this adsorbent material with zeolite. Okay, so now the zeolite takes in and changes the whole game here. That's the opposite property, the opposite one. It adsorbs nitrogen into itself and let go oxygen through it. You see the graphical representation of the gases here. So this was all about the molecular sieve functioning, and this is how we can extract oxygen from those nitrogen plants. So already the whole infrastructure of this is already been set up, and we just have to change those molecular sieves. Here you can see the industrial diagram of this thing. It has been separated into 5 processes, the 5 steps. This is what I've explained you in the earlier phase. So you can see how these processes happens. First of all, the compression happens, then it goes through a filtration process, and then other things like adsorption happens, and then we accumulate nitrogen into the nitrogen buffer, and then it is being transported to all the specific places. IIT Bombay professor, in collaboration with Tata engineers, have made this happen in the laboratories. We just have to transform it into the ground reality. And I hope all the paperwork gets done and it is implemented to all the nitrogen industries. I hope this video has added a little bit of value to you, and if that is the case, share this video with your friends and subscribe to NetMesh. This is Sourabh signing off.